All right, so looking at chapter 6, review number 2, preparing for the last quiz, the second quiz in chapter 6. So this section of the chapter focused on logarithms, and so that's what this quiz is going to be on. First two sections are about switching between exponential and logarithmic forms. So it is important that we remember this basic concept, right? If we have exponential form, b to the y power equals x, then we also know that the log of, with base b, of the x value is equal to y. Right? So we can use that relationship to switch between forms. So looking at examples or review questions 1 and 2, we are in logarithmic form. I would label things out. Log base b of x equals y. So that when I substitute in to b to the y power equals x, I have everything labeled out. So this just changes to 3 to the 4th power equals 81. Right? No calculator work involved here. You could plug in the 3 to the 4th power to check, but all we're doing is rearranging from exponential or logarithmic form to exponential form. So here I have b x y, right? Log base b of x equals y. I'm changing that b to the y power equals x. So 2 to the negative 3 equals 1/8. Second section, switching from exponential to logarithmic. So b to the y equals x. I know log base b of x equals y. Right? So log base 3 of 243 equals 5. Right? All I'm doing here is rearranging. So log base 2 of 1 over 16 equals negative 4. Right? So this is the key concept here that you need to be able to remember and use in order to be successful on the test. Right? And all we're doing is switching between these two forms. So this next section, change of base property, is the big part of what we are going to do here. So we know that if I have log base b of x, I can change that into common base log of x over log of b. Right? Our calculators only have just the common log or log with a base 10. We can't change the base. So we're going to use this change of base rule. Right? So the way this is often remembered is log of big over log of little. This gets a little tricky because it's the font size, not the value of the number. So for number 5, the calculator, you're going to type in log of 16 divided by the log of 4. Right? And the calculator, when you do your logarithms, when you hit that log button, it automatically pops up with a parenthesis. Right? So log of 16, and make sure to close that parenthesis, divided by log of 4. Right? So my solution there is 2. Number 6 is going to be log of 16 over log of 8. Right? That b value, that base, stays on the bottom. And so here I have log of 16 divided by log of 8. And I get 1 1/3 be represented as 4/3 Either way, good enough. But if we do have to round, we're going to go to 3 decimal places. 7, the tricky part about 7 is a lot of people get this upside down. Log of the x value, log of the big number, right? The 6 is physically larger than the 36 that's a subscript, right? So the 36 is your base. It stays on the bottom, right? So make sure that that's what you're typing into the calculator. And my 6 didn't take here. There we go. Log of 6 over log of 36, and I get 1/2, or 0.5. And then number 8, you would do log of 1 over 64 divided by the log of 4 for a solution of -3. Right, so those 4, you're just using that change of base, log of big over log of little. So 9 through 12, we start looking at solving logarithmic equations. Lots of various properties that we talked about throughout the chapter, but the first couple things I always look for is, can I evaluate something? Right, so looking here at number 9, can I evaluate this log base 2 of 2x? Well, because it has a variable, I cannot. And that's going to be the case for all 4 of these, right? We cannot evaluate the logarithm. So the next thing I would look at is changing the form, right? So right now we're in logarithmic form. We're going to look at changing to exponential, right? So we're starting with log base b of x equals y. And we want to change these all to b to the y power equals x. And see if that gives us easier path to a solution. So here for number 9, we're going to write 2 to the 3rd, or -3rd, right? 2 to the -3. My b value is 2. My y value is -3. And that equals 2x. Right, so now I have something on the left side that I can evaluate. You may know 2 to the -3rd would be 1 over 8, or you can just type it in, right? 2 to the -3. It's going to give it to you in decimal form, but we can work with that, right? 0.125 equals 2x. Now we're just going to use our basic algebra, right? Divide out the 2. And then you could calculator that, but it would be 0.0625. Right? If you don't believe me, right there it is. Right? So that's going to be our strategy for these 4. Changing the form and then seeing if we can solve, right? So my base is 16 here, my y value is 1/2, and that is equal to x over 3. So I need to evaluate 16 to the 1/2. That's the same as square root of 16, but I can just type in 16 caret 1/2, making sure to put the 1/2 in parentheses. If you don't, it's going to say that the answer is 8, and the answer is not 8. The answer for that, the simplified form of 16 to the 1/2 is 4. Right? If you don't put those parentheses, it's going to take 16 to the 1st power, and then take that value of 16 and divide it by 2, and that's not what we want. Another thing you could do is just use decimal form. You could say 16 to the 0.5. Okay, now that I have 4 equals x to the 3rd, 4 equals x over 3, I want to get rid of that division. I want to multiply out the 3. Right? These 3's would cancel. I'd be left with x equals 12. And that's going to be the strategy to finish out these last 2, right? I get 2 to the 4th equals x plus 3. 2 to the 4th is 16 equals x plus 3. And then when I subtract out this 3 here, I would get x equals 13. Number 12, 8 squared equals 4x plus 4. 8 squared is 64 equals 4x plus 4. And then I just start, right, working to isolate x. So I subtract 4 from both sides, and then I would divide out the 4. So I would get x equals 15. Right, so a go-to strategy is to switch the form. I can continue to use that on 13 and 14. Right, so 13 b to log base b of x equals y. So b to the y equals x. So x to the third equals 125. So I need to get x by itself. I could do some guess and check on my calculator. 1 to the third, 2 to the third, right? And keep going with that. The other strategy then would be to get rid of the exponent, right? So to do that, I would multiply each exponent by 1/3, or take each side to the 1/3 power, which is the same as taking the cubic root, right? We're taking the cubic root of both sides. It's just a kind of a harder button to find on the calculator. So these exponents are going to cancel, and then I have 125 to the 1/3 power. Again, making sure to put that in the parentheses, equals 5. 14, 3 to the 4th equals x, right? B to the y power equals the x value. And then that one is just calculator work. 3 to the 4th, I get 81. Right, so that's going to be the end of the change the form strategy for a bit. 15 through 18, looking to solve. And when you have a logarithm on both sides, changing the format is not going to help you. But what we do have here in the first couple, right, they both are log 5 and log 5 on both sides of the equal sign. So because those are the same, we need to make what is being taken to the log 5, right? So log 5 of on both sides has to be the same. I didn't state that very clearly to start with. But because these logs are the same here, these values here then must also be equal to each other, right? Which is why we set them equal to each other in this step. Right? So now I can use algebra, right? I'm going to subtract over an x, and then I can add over the 1 here, right? So here I get x equals 4. Same thing here in 16. They're both log 6, log 6. So the 3x minus 10 has to be equal to x. So I'm going to end up with 2x equals 10 after I subtract the x over, right? If I subtract this over, add that over, right? And then so x would be equal to 5. For 17 and 18, attempt at using the power property, but on 17 they're both 2 times the log base 7 of 4 and 2 times log base 7 of x. In reality, we could just drop down the x and the 4, but if you want to use this power property to its fullest, right, we would get log base 7 of 4 squared equals log base 7 of x squared. Then I can drop down these 2 terms. Well, if I square root both sides, I'm back to x equals 4, which I saw here to begin with. And again, that only works because these numbers out in front are the same. In 18, they're not the same, right? So I have 3 log 5 of x and log base 5 of 64. So I need to get this 3 here out from in front of the logarithm. So the power property says I can make that an exponent on the x, right? So this would become log base 5 of x to the third equals log base 5 of 64. Right, now that they're both log base 5 on both of these, I can then bring down just the x to the third equals 64. Right? And then I can cube root or take each side to the 1/3 power. And I can plug that into the calculator if I need to. 64 to the 1/3 power. And my answer there is 4. Closing out our review, we have two equations here, and our instructions tell us to take the log of both sides, which we could do, and then use the power property. The thing that makes the most sense to me here is to do what we've always done, right? Can I evaluate anything? No, I cannot. Can I change the form? Well, let's try, right? So I have b to the y equals x, and I want to change that to log base b of x equals y. And let's see if that will help us solve, right? So log base 5 of 106 is equal to 3b. And that does help me because this right here I can evaluate in the calculator, right? I can plug that into the calculator, right? Log of 106 over the log of 5, right? And I don't get a pretty answer, but I can evaluate that, right? So this value, log 5 of 106, is 2.8975 and on, and then that is equal to 3b. So to close it out then, I am going to divide, right, both sides by 3. And I'm just going to do that all right in the calculator, why I put 3 lines there, right? And I get the 0.966 rounded to 3 decimal places as told in the instructions. 20, I'm going to do the same thing, right? B, y, x, log base 5 of 17 equals w plus 3. So I'm going to evaluate the log base 5 of 17 on my calculator. Log of 17 divided by log of 5, right? 1.760. And then I can subtract away the 3 from over here, right? Subtract 3 from both sides. So I'm going to get w equals negative 1.240, rounded to 3 decimal places. Right? So strategies: can I evaluate anything, changing the form, and then using various logarithmic properties if needed. I hope that was helpful, and so that you are better prepared for your upcoming quiz.